The example of how heart disease is linked to fast food is an example of slippery evidence. Specifically, it is an example of how data can sometimes be misleading. In this scenario, the scientist is claiming that fast food is linked to heart disease. Though fast food may contribute to one's poor health, this is a misleading statement. The scientist fails to acknowledge the amount of fast food one must consume in order to permanently do damage to one's heart. The scientist's misleading data is an example of how slippery evidence can interfere with human inference. Oftentimes, humans are likely to make an inference based on whatever information is given to them, right or wrong. Therefore, they can often make incorrect inferences. In this case, the scientist saw that fast food speeds up the heart. He then proceeded to infer that it puts extra strain on the heart and thus causes heart disease. He fails to really explore the subject matter and investigate how much fast food and how often one must consume fast food before he contracts heart disease. The second scientist further explored the connection of heart disease and fast food. He claimed that there is an association, but he did not claim that fast food causes heart disease. He did not make this claim because he did not know the previous health of each person involved in the study. He was unable to choose who ate fast food daily, occasionally, or not at all. As a result, the people who ate fast food might have already been at higher risk of heart disease versus the people who omitted fast food from their diet. Correlation is the visual straight line association between two things. In contrast, causation occurs between two things when one thing causes the other. A correlation coefficient is a common numerical measure of straight line association, always between -1 and 1. This is an example of positive correlation. This is an example of negative correlation. And this is an example of no correlation at all. An example of when correlation and causation are the same could be when comparing deaths around the world and people being struck by lightning. The chances of being struck by lightning are slim, but could be correlated with some deaths around the world. In addition, when lightning strikes a person, it is likely to cause death. Therefore, the amount of people getting hit by lightning in relation to the deaths around the world is an example of when correlation and causation are likely the same. Correlation and causation are likely not the same when comparing being from the projects in relation to the number of kids in juvenile detention centers. There may be a correlation that many kids from the projects end up in detention centers. However, where one is from does not cause them to end up in these juvenile detention centers. Correlation and causation are two very important terms in relation to slippery evidence. In Module 1, I have learned how human inference can be a lot trickier than it appears. Oftentimes, the two terms, correlation and causation, appear to be the same thing. However, it is important to understand that that is not always the case. Just because something can be associated with another does not mean that it causes the other thing to occur. There are many other variables, like lurking variables, which can cause a different outcome of gathered data. This is why slippery evidence makes human inference difficult.